Hello, calculus fans. Let's now suppose that a ball is dropped from the top of the Washington Monument in Washington, D.C. That's 170 meters high. We're going to find the instantaneous velocity of the ball when t is equal to 2. This is not the average velocity, which we had computed last time, so this is slightly different. So really, the trouble is that we're trying to find the velocity at a single instant in time. There's no intervals involved. So everything that we did in the previous problem, where we calculated average velocities, they won't work. So what we're going to do is compute average velocities over smaller and smaller time intervals, and then we'll see what those average velocities tend towards. Now remember that the distance that an object falls is 4.9 t squared. And the average velocity, well, we can compute that. It's delta s over delta t. That's distance traveled divided by time elapsed. Let's try the time interval 2 to 2.1. It's a very small time interval, smaller than what we had done before. This is a time interval that only lasts 0.1 seconds. That's fast. So v is equal to 4.9 times 2.1 squared minus 4.9 times 2 squared, all over 2.1 minus 2. If we work all this out, we end up with 20.09. That's an average velocity. Well, let's go ahead and make a table of average velocities over various time intervals. So here is specifically the time interval 2 to 2.1. We got an average velocity of 20.09. All right, so I went ahead and did it for a bunch of time intervals. You can see the first one that we just talked about, and I did it for a whole bunch of other ones. Notice that we also have time intervals that are where the t values are a little bit less than 2. Now it seems reasonable that we can make a conclusion about what the instantaneous velocity at t equals 2 is. Looks like it's that these values are approaching 19.6 meters per second. We haven't proven this, but it seems reasonable to conclude this. Okay, that's all for now.